All right, so we're ready to tackle the reciprocal graphs. Good news is it's really not that much work once you know how to graph sine, cos, and tan. So you'll see as we go to graph these three new functions, I'm going to start with what we already know. We're going to start with a cotangent graph. I have already taken the time to graph a tangent on the set of axes. So I have an asymptote at negative pi over 2 and positive pi over 2. I've got my curve going through 0. Halfway on the right side, it's up at 1. Halfway on the left side, it's down to -1. So I'd like you to start with that graph. So go ahead and pause this video just so you can get the tangent graphed on there. And then when you're ready, go ahead and hit play and we'll get the cotangent done. All right, so hopefully you have the tangent on there, looking like mine. Now we're going to turn this graph into a cotangent. Let's start with the asymptotes. Remember, an asymptote was graphed for tangent because the value didn't exist. It was undefined. It came from the fraction 1 over 0. If we're talking cotangent, though, we need the reciprocal of that. So the value of 1 over 0 is getting flipped over and turning into 0 over 1. And that's just 0. So anywhere tangent has an asymptote already graphed, cotangent will have a 0. It's going to have a point on that midline. So I'm putting my cotangent in blue so just so we can see the distinction between the tangent and the cotangent. Now, tangent has a 0 right in the middle. But again, if we think about that reciprocal value, turns into 1 over 0, and that's undefined. So cotangent's 0 turns into, I'm sorry, tangent's 0, let's get that right. Tangent 0 turns into cotangent's asymptote. I'm just putting it off to the side a little bit so we can see it on the axis. So basically, they're just flipping places. A 0 turns into an asymptote turns into a 0. Now remember, tangent also has two additional points plotted. Halfway through the period, or halfway between the two things, I went up to 1 and I went down to -1. Again, let's take those reciprocals. These are even easier. The reciprocal of 1, when we flip it over, is still 1. So cotangent's also going to have a point right there on 1. -1, when you do its reciprocal, still -1. So it still has a point there at -1. And that's really all we need for a cotangent. I'm now going to connect the dots. You're going to see some similarities for the tangent. Okay, so cotangent started at negative pi over 2 and headed down, asymptote at 0, and then the other side was from pi over 2 going up. Okay, so that is what our cotangent looks like. I'm going to erase my tangent real quick just so you can see it, but that's what your cotangent will look like. Okay, negative pi over 2 down, asymptote, and then the other side's heading up. Now, as you graph these, and as you graph any of these, I'm okay with you keeping both on the graph, just telling me maybe with an arrow or drawing it darker what your actual answer is. But that's what a cotangent is going to look like. We will do the example in class together. So I'm going to go ahead and scroll to the next reciprocal function, which is your secant. Now remember, secant is the reciprocal of cosine. So again, I went ahead and graphed my cosine already on this set of axes. So I went from 0 to 2 pi, I got my 5 points plotted, started at 1, ended at 1, etc. So go ahead and pause me, get this graph, and then we can turn this into a secant graph. Okay, hopefully your cosine is done. Let's again think about reciprocals and turn this into a secant. Now remember when we did the cotangent tangent one, anytime that tangent was 0, which was right in the middle, it turned into an asymptote. And that's going to happen again here. Cosine is 0 at pi over 2. If we think about the reciprocal of pi over 2, or the reciprocal of that number 0, it's undefined. So where cosine is at 0, secant's going to have an asymptote. Okay. Now, as we move these cosines around, basically anytime cosine is on the midline, that's where we're going to have an asymptote for secant. Okay. So it's not just because it's 0, it's anywhere we're on the midline. Now let's think about the other three critical points that we plot. Cosine starts at 1. The reciprocal of 1 stays 1. So that's also going to be a point for our secant. The minimum is at -1. That reciprocal, still -1. So that's a point for our secant. And then back at 2 pi, back at 1, still a reciprocal of 1. So the maximum and minimum points stay the same for your secant and your cosine because the reciprocals are the same. Even as we stretch and shift and move, the maximum points will stay the same, the minimum points will stay the same. Now, what secant's going to do is as cosine heads down from 1, secant's going to do the reciprocal of that and head up. So that's going to be a curve going up. That middle section, cosine's coming, well, it's coming down, but secant's going to do the opposite and curve the other way for both sections. So it's almost like we're taking that cosine and just kind of reflecting it to get its reciprocal. And then same thing with the last section. The secant is going to do the opposite direction. So if cosine's really kind of cupping down, secant is going to cup up. Okay, so it's a series of curves separated by asymptotes. Again, I'm going to erase my cosine. Look at that. That's what a secant looks like. Okay, so you can kind of imagine the cosine that's connecting the points in the middle. And again, that's how I would draw it. I'm not going to memorize this shape or this function. I'm going to draw a cosine and then turn it into this. And that's what I would be totally fine if you do also. Don't waste the brain power on memorizing this. Okay, just know how to change it. So that's your secant. And the last one, cosecant. Again, hopefully you can see we're going to do the same thing. I've already got my sine graphed. So go ahead and take a second, graph your sine, label your axes, and then we're going to turn this into a secant. And if you're feeling really good, go ahead and turn it into a secant before you start the video again. Or cosecant, not secant, cosecant. Okay, so if you have it graphed, we're going to check. If you don't, we're going to talk through it real quick. But this is the same idea as what we just did with the cosine and the secant. Anytime we're on the midline, we are going to have an asymptote for our reciprocal. So sine or cosecant is going to start with an asymptote. It's going to have an asymptote straight down the middle, and it's going to end with an asymptote because those are all the places where sine is on the midline. Maximum point is going to stay the same. Minimum point is going to stay the same. And then we're just going to curve away. So since sine is kind of curving down, secant is going to, or cosecant, I keep saying secant, cosecant is going to curve up, and then the same at the end. It's cosecant is just going to do the opposite direction. So I'm going to, again, erase this, and you can see exactly what a cosecant looks like. Asymptote, curve up, asymptote, curve down, asymptote. It's almost a series of parabolas, which is really the same as the secant. We're just seeing the complete parabolas here. So that's how we're going to graph our reciprocals. Pretend that it's a sine or a cos or a tan, draw that, and then we'll change it into the reciprocal graph.